Hello, my name is Kyley Stazewski, and in this video I will walk you through a complete structural interpretation of a compound with the molecular formula C7H14O2. I was given group F along with these charts that you see right here, along with that guy there. So I will use these charts and explain how I used infrared spectroscopy, carbon-13 nuclear magnetic resonance spectroscopy, and protein nuclear magnetic resonance spectroscopy data to determine the correct structure. Let's begin. So, we are going to go ahead and start with the DU. First, I was given the task to calculate the degree of unsaturation, abbreviated as DU. The degree of unsaturation is a simple calculation used in chemistry to tell us the total number of rings or pi bonds in a molecule. It helps to determine the possible structural arrangements as well, and it's especially helpful when we're determining the molecular formula. So if we look down here, I have my calculations. So the original formula for DU is written as 2C plus 2 plus N minus H minus X all divided by 2, where C is the number of carbon atoms in a molecule, N is the number of nitrogen atoms in a molecule, H is the number of hydrogen atoms in a molecule, and X is the number of halogen atoms. So, looking at our formula, there are 7 carbon atoms, 14 hydrogen atoms, no nitrogen atoms, and no halogen atoms. Thus, we get our formula 2 times 7 plus 2 plus 0 minus 14 minus 0. We all divide that by 2, we get 1. So the du of the equation is 1. So, a du of 1 indicates we either have a double bond or a ring. Given the IR and NMR data, this likely indicates a carbonyl group, in contrast to a ring or a double bond in a hydrocarbon chain. Looking at the IR spectrum, so this little chart right here, I observed 1,735 wave numbers. The strong absorption near 1,735 is a characteristic of an ester carbonyl stretch, not a carboxylic acid. The absorption taking place between 1,150 and 1,250 indicates a carbon to oxygen stretch. I want to point out there was no absorption around 3,300, which indicates no hydroxyl groups are present, which means we're not looking at an acid or an alcohol. This data strongly suggests that an ester is present as the functional group. Moving on, we can look at the carbon-13 nuclear magnetic resonance, which is this little chart right here. So the carbon-13 nuclear magnetic resonance spectroscopy show distinct peaks at 174 parts per million, which correlates with an ester carbonyl carbon, and at 51 parts per million, suggesting a methyl group attached to oxygen, and between 34 and 22 parts per million, indicating an aliphatic CH2 groups, and finally at 14 parts per million, indicating a terminal methyl group. Moving on to the protein nuclear magnetic resonance spectroscopy, which is this chart right here, it further supported our findings. So the 3.6 parts per million singlet clearly represents the ester methyl group, and the triplet at 2.3 parts per million indicates a methylene group next to a carbonyl. The remaining singlets account for a straight chain alkyl group. Putting all of this information together, from the degree of unsaturation, the ester IR peaks, the consistent NMR data, it leads us to the final structure, which is methylhexanate. So there's the formula. This is the structure right here. Thank you for watching. I hope that this provided a clear and concise answer to the problem. Have a great rest of your day.